Okay, hello everyone. So today we are factoring a greatest common factor. You'll notice on this problem there are three different terms. So I would call this a term, and then this addition or subtraction symbol will separate the terms from each other. So we have one term here, we have a second term, and a third term. So we would refer to this as a trinomial because there are three terms. Now, what I'd like you to do is the same thing we did last week. We're just going to make a complete factor list for each term, and then we'll decide what the greatest common factor is. So 45, I'd like just to start with the numeric part. The factors of 45 are 1 times 45. 2 does not go into 45 evenly, but 3 does. 3 times 15. 4 does not. 5 times 9. And that is all the factors of 45. The next thing you're going to look at is the variable component. So q to the fourth, that just means q times itself 4 times. And then p to the fifth is just p times itself 1, 2, 3, 4, 5 times. Okay, so then we're going to move on. We have all the factor list for 45 written out. We're going to move on to 36. Factors of 36, 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 does not, but 6 times 6. We have q. This is just q to the first power, so that's just q is all that is. And then p to the sixth, well, that's p times itself 1, 2, 3, 4, 5, 6 times. Okay, and we'll move on to 81. All of the factors of 81. 1 times 81. 2 does not. 3 times 27. 4, 5, 6, 7, 8, 9 times 9. And then we have a q squared. So q times q. And then p cubed is just p times p times p. So when we decide the greatest common factor, we are looking for the largest factor in all three lists. So I'm going to start with the numeric part. I have 145, 315, 5, 9. And there's no 15 in the second list or 45. So I'm thinking the greatest common factor, the numeric part, is going to be 9. Again, that's the largest number that appears in all lists. But I also have a variable part. I need the largest variable part that's common to all three lists. Now, the biggest q term is just q. Since there's only a single q in this middle term, the greatest common q component is just q. And then as far as p goes, there's only 3 of them over here. So 3 are common to all three lists. So I would write p to the third. Now my greatest common factor altogether is 9q p to the third. So then what we're going to do is we're going to factor it out. And again, this is just the distributive property in reverse. So I'm distributing 9q p to the third times something will give me my first term here. Now 9 times something to get 45, that's a 5. So I have 9 times 5 is 45. I need to multiply q times something to get q to the fourth. So that's q to the third. And then I have to multiply p to the third times something to get p to the fifth. I will have p squared. So my entire first term is done. 9 times 5 is 45. Q times q to the third is q to the fourth. P to the third times p squared is p to the fifth. Okay, we'll move on. Plus 9 times something is 36. 9 times 4. I already have a q. Q times something is just q. We don't need to write a q term at all because we already have it. P to the third times something is p to the sixth. P to the third. P to the third times p to the third is p to the sixth. Okay? Our middle term is done. Plus 9 times something is 81. 9 times 9 is 81. Q times something is q squared, so that's just q. Q times q is q squared. P to the third times something, I just need p to the third, so I'm done. So once I factor out my greatest common factor, this whole thing is my answer. We factored out a greatest common factor, 9q, p to the third. And what we have left is 5q to the third, p squared, plus 4p to the third, plus 9q. And now I know that I'm completely done, since there's no greatest common factor in the parentheses anymore. There's no common factor of 5, 4, and 9 other than 1. There's no q common factor because there's no q term here. And there's no p common factor because there's no p term over here. So this is a final answer. Okay? Have a great day, folks.